wrong. So welcome to the first live session of the course, that is Computer Vision and Image Processing, Fundamentals and Applications. So this is the first live session of the course of Computer Vision and Image Processing, Fundamental and Applications. So if you have any doubts, because up till now we have covered up to week number 5th. So week number 1, week number 2, week number 3, week number 4, and week number 5th. So if you have any doubts or if you are not understanding any concepts, and then you can interact with me in this live session. And I have some questions in the shared Google file. So the first question is about the radon transformation. So you have to determine GS theta. So that question is regarding this how to determine the GS theta. So the solutions for this will be given maybe after next week, because we have all the assignments and the solutions will be uploaded maybe after 1 week. So the first question is regarding how to determine GS theta. fxy is given, the function is given, and corresponding to this function, we have to determine that radon transform of the function. So this is about the first question. The second question I have seen, and that is from the liver image for the liver ultrasound video to frame extraction, which is the best approach to maintain both spatial and temporal information in image. So any ultrasound video, suppose if I consider, so from the ultrasound video, we can from any ultrasound video, we can extract the key frames. That is the most informative frames of the video. So suppose if I consider a particular video, and from this video, we can extract the key frames. And that is the most informative frames of the video. So by some techniques in computer vision, so you can see some papers, research papers on this, how to extract the key frames. So only the informative frames of the video can be extracted. And with the help of the key frames, it is possible to do the interpretation. So we can interpret. And these key frames can preserve both spatial and the temporal information. So that is actually the concept of the video summarization. So in the video summarization, we generally extract the key frames of the video. And by some techniques, like the video summarization techniques, we can extract the key frames. And that is the most informative frames of the video. So this is about the second question. So I have only these two questions in the Google Sheet. So now any questions if you want to ask me here in this live session, you can write in the chat box. So you can see in the YouTube link table, I am live now. So if you have any doubts on the concepts, what I have explained in the lecture number 1, week number 1, week number 2, week number 3, week number 5, so that you can interact with me. So if you are finding any problems in understanding this concept, then this you can interact with me. So regarding these courses, if you see the outline of the courses, so in the week number 1, you can see what we have discussed. So in the week number, let me check this one. So what are the concepts we have discussed in the week number 1? So in the week number 1, actually the first one is I introduced the concept of image processing and computer vision. And also I discussed some fundamental concepts of image processing. So that is about the week number 1. So for week number 1, just you have to understand the image processing concepts and also the introduction to computer vision. The week number 2 is very important. That is the fundamental concept of image formation. And I actually in that week I discussed the concept of the radiometry. Radiometry means the measurement of light. So the concept of BRDF, and also the concept of the photometric stereo. So all these things we have discussed in the week number 2. And also we discussed about geometric transformation, like the affine transformation. And also I discussed the concept of geometric camera models. So that is week number 2. Week number 3 is also related to week number 2. So in this case, again, we are discussing the concept of geometric camera models. And main concept is the camera calibration, and also the concept of the image formation in a stereo vision setup. That is also one important topic, the stereo vision. And also I have discussed one concept, important concept, that is the image reconstruction from a series of projections. So that is nothing but the radon transformation. So I discussed how to determine the radon transform of an image or of a particular object, fxy. So from fxy, we can determine the GS theta. And also I discussed the concept of inverse radon transformation. So we discussed the two techniques. One is the back projection technique. Another one is the projection theorem, that is the Fourier transform method. So these two concepts I have discussed in week number 3. That is the image reconstruction from series of projections, and that is the concept of the radon transformation, and also the inverse radon transformation. After this, the week number 4, we discussed the basic image processing concepts, and mainly the concept of the image transformation, the concept of the DFT and the DCT, why the DCT is very popular. So all these concepts I discussed in week number 4. And one important concept is the properties of the transformation. So like the decorrelating property, the energy preserving property. So all these properties we have discussed in week number 4. That is the concept of the image transformation. Week number 5, again, we discussed the concept of image transformation, and we discussed the concept of wavelet transformation. So what is the definition of the wavelet transformation, and the concept of the hard wavelet transformation, and how to decompose a particular image into number of components, low frequency component, high frequency component, with the help of the wavelet transformation. So that concept I discussed in week number 5. And finally, in week number 5 also, I discussed the concept of image enhancement. So how to improve the visual quality of an image. So we discussed about the spatial domain approach and also the frequency domain approach. In spatial domain approach, we considered the manipulation of the pixel value directly. And in frequency domain, I considered the concept of modifying the Fourier transform of the image. So this is about the week number 5. So up till now, we have discussed up to week number 5. Week number 6 is mainly the concept of image filtering, color image processing, image segmentation. Week number 7 is the features, image features like texture features, color features, edges and the boundaries. Week number 8 is the image descriptor and the features. So object boundary and the shape representations. Week number 9 is image descriptor and the features. So for this, we will be discussing about the corner point detectors, the HOG, the histogram of oriented gradients, shift features, and also the speeded up robust features, the concept of the saliency. So that will be discussing. That will be discussed. And week number 10 is the fundamentals of the machine learning, like the concept of the linear regression, and the Bayes decision theory, the parameter estimation, clustering techniques, dimension reduction, linear discriminant analysis. So all these concepts will be discussed in week number 10. And week number 11 is the application of computer vision. So mainly the concept of the artificial neural networks and also the convolutional neural networks, autoencoders. So the fundamental concepts of the ANN and also the convolutional neural networks. And finally, in the week number 12, we discussed the concept of some like gesture recognition, motion estimation, object tracking. These are the applications of computer vision, and also some of the programming assignments we are considering. So this is the course outline for this computer vision. So in this live session now, if you have any questions, then you can ask me in this live session. So time is very limited, so only 1 hour time for this live session. So So if you have any questions, then you can ask me. So you can see the set box in the YouTube link. So in the set box also you can write your questions. So if you have any questions, then you can write in the set box. So this is the first live session of the course of computer vision and the image processing fundamentals and applications. The first live session of the course on computer vision and image processing fundamentals and applications. So up till now, I discuss the basic concept of computer vision and image processing up to week number 5. So if you have any questions, then just you can write in the chat box. So one question I have seen in the chat box. What is the question? Oh, here in the Myra. No, I am not giving any presentations in the full screen. So I am not showing any presentations. So only I am replying your questions. So one question I have seen, that is, sir, I am trying to build a model using computer vision pneumonia detection. Detection from X-ray. Is it possible to identify defective region inside an pneumonia? Yes, it is possible. So you have the X-ray images and maybe some the problems in the lungs, like cup deposit or maybe some tumors or any other problems that you can determine. So for this, you have to do image processing, and also for detection, you can apply computer vision algorithms, and also you can go for classifications. Like suppose if you have a tumor in the X-ray, that is the CIS X-ray. So whether tumor is a benign tumor or the malignant tumor. So that type of classification you can do. So it is possible. Just you have to collect the images, and from the images, just you have to do the image processing for enhancing the visual quality of the image. And after this, you can apply the computer vision algorithms for detection and also for classification. So another question is by Sandra. Can you give short notes about the motion detection and optical flow? Yes, definitely in week number 12. Week number 11, we are week number 10, I think, week number 10 or 12, I forget that one. So I'll be discussing the concept of the motion detection and optical flow. So now currently we are in week number 5. So you can see that in week number 10, from 10, 11, 12, you can see the applications. And you can see that this concept, the concept of the optical flow and also the concept of the motion detection. Yes, more than classifying, need to identify the defective region of the X-ray. Yes, it is possible because you have that one is the normal X-ray image for a normal person, and also the another one is the problems, the medical problems. You have two images. So from this, actually, you can compare these two, or you can identify any defective regions in the X-ray image. That is possible. So you can see our research papers on how to detect these problems. And mainly we considered the endoscopic images, endoscopic videos like this. So for this, actually, we are applying the computer vision algorithms and also the machine learning algorithms for detection of anomalies or any problems in the images, like the endoscopic images, the colonoscopic images, or ultrasound images. That is possible. So for classification, you have to apply the machine learning algorithms, and for detection also it is possible. So one question is Kotapalli, Dr. Kotapalli. Good afternoon, sir. I am faculty enrolled to learn computer vision image processing. Kindly suggest hardware module embedded system to perform basic applications. So mainly these FPGA systems, that hardware FPGA implementation is possible. So the basic, also the DSP, the kits are also available, but I think the FPGA systems are also available for the hardware implementation of the image processing algorithms and also the computer vision algorithms. So you can see, you can search in the internet the FPGA architectures, because you can see my research papers on FPGA implementation for the DCT algorithms, the DFT algorithms. So this is possible. So one question is, okay, so another one in ultrasound videos, the tumor is moving with very low light. So how we detect the tumor using object detection technique? So tumor is mainly in ultrasound images. That means some abnormality is there. So if you consider the video, then maybe the temporal information may be considered, because you are mentioning that the tumor is moving with a very low light. So that means for low light conditions, you have to do some image processing, the image enhancement techniques, so that you can improve the visual quality of the images. And if you need the temporal information, then you can extract key frames of the video. That is the most informative frames of the video. And that is called the video summarization. So you can extract the most informative frames of the video, and that is nothing but the video summarization. And you will get the temporal information. Like you can increase the brightness of the image, you can increase the contrast of the image. So these type of things you can do in case of the low light condition, or maybe the tumor is not detected properly. So these type of things you can apply. Dr. Kotapalli, thank you. So you have to understand the algorithms, and after this you have to see how it can be implemented in the FPGA architectures. So another question from him. So sir, how to start autonomous navigation? This autonomous driving is one important problem, is the segmentation. So you can see my research papers on autonomous driving. So for autonomous navigation, one problem in case of the computer vision is the image segmentation. And that is actually the semantic segmentation. So suppose the vehicle is moving, and you have to segment out the objects, the stationary objects and the moving objects. So all these objects you can do the segmentations, and that is actually the semantic segmentation. So the one computer vision problem is the segmentation, and after this also the estimation of the depth. So for autonomous navigation, depth is also important. So at what depth the object is present, your vehicle is moving, and at what depth that particular object is present. So that is the depth information is important. So another problem is the depth estimation. And also how to detect the stationary objects and also the moving objects. So there are many problems for the autonomous navigation. So you have to read the papers, and currently actually we are doing on image segmentation, video segmentation. for the autonomous driving, something like this. So you can see in my research papers that we are doing this type of things for autonomous driving. So that is one important topic in computer vision. So OLO, that actually this OLO concept I am not going to discuss in this course. So OLO concept, you can see OLO 7 is now available. You only look once. That is the OLO means that you only look once. That is the one deep architecture. So I think it is available in the internet also. You can see the concept of the OLO. But in this course, I am not discussing about the OLO. So I have another course on machine learning. That in machine learning, I discuss many deep learning techniques. You can see in the next semester, the machine learning and the deep learning course, NPTEL course. And that course, I am explaining many deep architectures, the concept of the deep architectures. So that is available. Otherwise, in open source, the concept of the OLO is available. That is a deep architecture. Sir, can you give some open source public dataset on medical liver dataset using ultrasonography? No, I don't have this dataset. I am not working in this liver dataset. My main works, if you see my research publications, mainly on endoscopic images, colonoscopic videos, images, lung images, and also something like the skin cancer database or oral cancer database. So I am not working in this domain, that is the liver dataset. So another, can you comment on the efficiency of disparity map for negative obstacle detection in autonomous? So mainly the disparity map is considered to estimate the depth information. So suppose if I have a stereo vision setup, so from the stereo vision setup, we can determine the disparity map and we can determine the depth information. So that is obstacle also we can determine. But one point is important, that is the calibration of the camera is important. Then only it is possible to detect the depth information properly. So that is why in stereo vision setup, the two cameras will be available. And from the two images, the left image and the right image, we can determine the disparity map. And from the disparity map, we can determine the depth map, or the depth we can determine. And that depth information is quite important for autonomous navigation. So in my the stereo vision lecture, you can find this concept, the concept of the disparity map estimation. And from the disparity map estimation, we can determine the depth information. So if you have any questions, then you can write in the chat box. I am available. So this is the first live session of the course on computer vision and image processing, fundamentals and applications. So Subrata Sarkar, good afternoon, sir. Could you suggest some books reference for problem solving in digital? So for digital image processing, you can see the book by Gonzalez that already in the introduction class, I have mentioned about the book by Gonzalez. And for basic understanding of the course, you can see my book. Book on computer vision and image processing. So that book also you can see the understanding of the concept. But for the problem solving, you can see the book by Gonzalez, Image Processing by Gonzalez. So Dr. Kotapalli that explained the leader available for leader data for research. So I don't know about the leader data set is publicly available or not. I think it may be available, the leader data set. So you have to search internet whether it is available, publicly available or not. But I do not work in this domain. So, sir, can you elaborate regarding attention unit for the satellite image segmentation? So in this course, I'll be explaining, I think, the concept of the unit. Or maybe my machine learning course, actually, I explained the concept of the unit for image segmentation. So my videos are available in the YouTube. So the course is machine learning and deep learning, fundamentals and applications. So that will be running in the next semester. So if you want to understand this concept, the concept of the unit, you can see the video that is available in the YouTube. So you have to search the machine learning and deep learning, fundamentals and applications, and you give my name, MK Bhuyan. Then you can see the videos, the 42 videos for the course on machine learning and deep learning. And in that course, I explained the concept of the unit. So that unit is available in my videos that you can see the concept of the unit. So maybe in the next semester, you can see this course on machine learning and deep learning, fundamentals and applications. And otherwise, if you are interested, then you can see in the YouTube. So all the videos are available in the YouTube. Thank you. So one question from VSM, sir, which sensor is best suited for OLO model image segmentation? No, OLO, I am not discussing in this course. It is available in the course in machine learning. So you have to see the course on machine learning. So in machine learning course, you will get the concept of the OLO. So in this computer vision course, I am basically explaining the concept of the artificial neural networks and also the concept of the deep architectures like CNN, autoencoders. So that you can see in the video. So one is that, sir, may you please explain the difference between radiance and the irradiance? So that is the basic concept. The irradiance falling in a particular surface. So in my the concept of the radiometry, again you see my video, the radiance of a source and irradiance falling in a particular surface. Okay. So radiance means the flux per unit solid angle. So that is the radiance. And irradiance is the flux per unit area. So that you can see what is the radiance of a source and what is the irradiance in a particular surface. So one is the source, another one is the surface. So that concept I have explained in my lecture in radiometry, the first lecture. So you can see the concept of the radiance, irradiance, what is the concept of the BRDF, albedo. So all these things you can see in my the course on radiometry. So that my lecture is available. So you see that lecture on radiometry. So for this course, how many live sessions are available? For this course, I think 4 live sessions. So the second live session will be in the month of March. And there may be another 2 live sessions. So altogether, maybe 4 live sessions of the course. So if you find any difficulties in understanding, then that you can interact with me in this live session. So to become too strong in computer vision and image processing, which part of the mathematics we should focus? So first one is the concept of the probability and the random process. So that is the one important point, the probability and the random process. And second part is the linear algebra, the concept of the matrix information theory, how to determine the eigenvalue and the eigenvectors. So all the concept of the matrix information theory, or maybe the matrix, the linear algebra, and the probability and the random process. The calculus is okay because you have done in class 12, 11. So calculus you can do, but mainly the concept of the probability and the random process and the concept of the linear algebra and the matrix information theory. So another question by Lova, sir, instance segmentation model commonly used in research? Yes. So the semantic segmentation, instance segmentation models are also used in research. So you can find some research papers on semantic segmentation or instance segmentation in some of the research. So Anand, thank you.
Sir, I'm Priyabrata Mandal. Can I speak something?
Okay, please.
Sir, good afternoon. I'm Priyabrata Mandal. Currently, I'm an assistant professor, and I'm also doing my PhD.
Assistant professor in which institute?
Amity University, Kolkata.
Oh, okay, please. Yes.
Okay, sir. Actually, I have chosen your course for my PhD coursework. I'm doing my PhD from Anna University in Chennai.
Okay.
Okay, sir. Actually, the biggest challenging part is that actually I'm from a non-computer science background, and I am a fashion technologist. My area in the fashion engineering. So I really wanted to take implement some AI ML work in the fashion industry, basically in the production area. So that is actually my area of work, and my PhD area is actually identifying the micro motions and the small micro motions using any RGB camera. Okay, using the computer vision technique. So can you, sir, please help me that to formulate that how actually we should proceed, because I'm a non-computer science background. It is very difficulties that I'm facing. Actually, I have an understanding of linear algebra and matrix and probabilities that I actually am doing also, and also have done BTech and MTech degrees time. But the computer vision is a very new thing for me, and I'm facing a lot of difficulties to understand that where I actually need to start. If you can use that.
So do you like this course? Have you seen
yes,
my
sir,
videos?
Definitely, sir. I'm liking all this course. I'm actually answering all your assignments and all. I have prepared a big notes for you. Even you can see if I show you the video.
Okay.
That
so
regularly, yes, sir.
So one thing is that that for your problem, for the motion detection and for the by camera. So this is actually the video processing. Yes, so you have to take the videos by using the camera, RGB camera.
Okay, sir.
And after this, from the video, what you can do, you have to determine the motion, no? Your problem is the motion.
Sir, the problem here is issues that there are some standard motions in the garment industry. Okay, and I'm explaining in the actually common forum. There is standard motions in the garment industry. I need to identify those small motion and need to identify the value of that motions, how much time it takes. Okay, and then it helps me to calculate a particularly total standard time to prepare a garment.
Okay, for small motion, actually, you can see, I can share one video to you. Just wait, I'm sharing one video. Whether my screen is visible now?
Yes, sir. Yes, sir.
Is it visible now?
Yes, sir.
So here I am showing this video, suppose one video. I'm clearing one video. Have you seen any motion in this video? One baby is there.
By normal eyes can't able to see anything.
Oh, you have not seen any video. Now, I will show another video. Sorry. Yes, screen is visible, no?
Yes, the screen visible, sir.
Okay. Next, you can see the same video. I am doing the amplification of the video. Have you seen the video motions?
Yes, yes, the tummy is moving, sir.
It is moving.
The belly portion is moving. Even the fingers is moving in a
yes,
left hand side.
So that is actually that motion amplification can be done in the videos.
Okay.
So you can take the video and you can see some papers on motion amplifications.
Okay, sir.
So the small motion that is not visible by eye, so that can be amplified.
Okay.
And you can see that the motions. So in computer vision, this is available. That these techniques are available. So you can take the video by simple camera, and these small motions are not visible by your eye or maybe by camera. But after the amplification, you can see the small motions.
Okay, sir.
Like simple audio amplification, the motion amplification is also possible.
Okay, sir.
And based on the motion amplification, you can interpret what is going on. So after first you have to do the amplification, and after this interpretation is you can do by using the machine learning techniques or maybe other techniques you can do the interpretation of this.
Okay, sir.
So first part you have to do the motion amplification. You take the video and do the amplification by standard techniques. So if you search in the internet, you can see the papers on motion amplification. After amplifying the motion from the video, that amplified video, you can interpret what is going on, the interpretation of the video. That is possible.
Okay, sir. And sir, any mathematical approaches that requires for
so in some of the papers actually I have done. You can see one paper, my paper on motion amplification. Okay. Mainly we consider the wavelet transformation.
Okay, sir. And there are another areas that you have shown as the motion amplification. In case of garment industry, if I move my hand from one distance to another, it takes some time, sir. And then how to calculate these times? Any algorithm for that, sir?
No, time you can determine because in one frame you have the object. And after this, after some frames, you have the object in another position.
Another position, yes, sir.
So you know what is the frame rate? How many frames? 25 frames per second.
Okay.
So in one frame it is available, in another frame it is available. You can determine the distance between these two.
Okay.
And from the distance and the time, because you know the time information, 25 frames per second. So from this you can determine the velocity, you can determine.
Okay, sir. Got it, sir.
And this is actually the motion amplification. Motion estimation. It's called the motion estimation. So there is a question I have seen that is the problem solving sessions may not be available, but this programming the sessions will be available in week number 12. They are programming the sessions, OpenCV programming or Python programming sessions will be available. But I think the problem solving sessions I have to discuss with my TAs. So I think they can arrange one problem solving sessions. So if you have any problems, then you can directly contact the TAs of the course.
Okay, sure, sir. Okay.
So this motion amplification, you can search in the internet. We have also papers on motion amplification.
Sure, sir. I'll see your papers.
Okay, no? So you like that course? No?
Yeah, definitely, sir. I'm liking it. Yeah, it's actually helping me a lot. 2 courses I'm actually doing. One is from you, another is from Professor Sadananda Khade, sir. He's from IITG. So he's teaching as a linear algebra and applied ML, AI/ML.
So in next session in July, my course you can also see machine learning and deep learning.
Okay.
So it will be in the next from July.
Sure, sir.
So that is a very.
I could mail ID. We get your mail ID, sir.
Mail ID better. In the extreme case, you contact me. Otherwise, we have very limited time actually because so many mails we. So based on the page information, you can do the modulation. So that is the answer for this. So I think you know the name of the TAs. So for TAs, I'm giving the mail IDs of the TAs. So just wait for some time. So you can copy the mail IDs of the TAs and you can interact with them. So I am just giving the mail IDs of my TAs. So I am just giving the mail IDs of my TAs. So the next live session will be in the month of March. So you can see in my set box, I am giving the mail IDs of my TAs. So you can contact the TAs for any problem solving. So I am giving the email IDs of my TAs. So just you note down the email IDs of the TA and you can send the mails to the TAs of the course. So your next live session will be in the month of March. I think it will be in the first week of March. So that will be announced by the NPTEL. So for this course, just you see my videos and also the books. The book by me, that my book you can see, and also the book by Gonzalez. And after this, the small objective type questions like you are getting in assignments, regular weekly assignments. So similar types of questions you can expect in the NSEM.
Sir, one more question, sir. I actually have your book actually that I have taken it from the library, bought it from library. Sir, till now I have not completed and gone through the entire book actually. So I'm just asking.
My book you got from the library.
Yes, yes. In our library, your book is there. It's as a reference copy, it is there. So I'm just asking one thing, sir. I haven't gone through the entire chapter so till now. So whatever you have shown us that I'm actually running on. So regarding my PhD areas, is your book actually catering the most of the things related to the hand motion recognitions and gesture recognitions or computer vision techniques or related to this parts are?
So this is actually the book which covers most of the concepts in computer vision.
Okay, sir. Okay.
You will not get a single book covering many things in one book in computer vision. Only limited books, number of books.
Okay. Okay, sir. Thank you, sir. Thank you.
Machine learning and deep learning.
Sure, sir.
So if you have any questions, then just you can interact with me in this live session. So it is only for 1 hour. So yeah, my second live session will be in the month of March. So that will be announced by the NPTEL. So up till now, I think we have covered up to week number 5. So if you have any questions, that just you can put in the chat box. So, okay, if you have any questions, then again, you can put in the chat box. I'm available. Okay, so your mail ID is this.
Yeah, so, okay, sir. I've said my mail ID. In case, sir, like, when you free, sir, please reply me, sir.
Okay.
Thank you, sir.
So today, I think you understand how to do this motion amplification.
Yes, sir. Yes, sir. I need to check more of your papers, sir, that you have mentioned, sir.
The like wavelet transformation, Stockwell transformation, some transformation the people are doing. So just the low motion can be
those
amplified.
Are the linear transformations you need to do in that way, sir.
And after amplifying the motion, the interpretation is possible.
Okay.
In my video, you have seen that motion, no? That one is the without motion, another one is the motion amplification.
Yes, sir.
So that actually we have employed for the biomedical image analysis. So that camera is taking the videos. And if you see the motion of the arteries in the vein, that is not visible if you see from the normal eye or by the camera. And after this, what we have done, we are amplifying that motion. And from this, we are getting the motion amplified video. And after this, from that motion amplified video, we are determining the BP, the blood pressure and the heart rate, because the pulse rate you can determine.
Okay, sir.
So that is the motion actually. So the pulse we can determine from there. So your heart rate and your BP. So if you read my papers, research paper in my web page, you can see in my web page. So this RPPG signal and these signals we have amplified. And after this, we are determining the heart rate and the BP, the blood pressure.
Okay, sir.
So you are doing in Anna University?
Yeah, sir, Anna University, College of Engineering, Guindy.
Yes, I used to visit there. No, I am the examiner in many PhD theses in Anna University.
Okay, sir.
So I have a talk there on 26th March. 26th, 27th March, I have a talk.
They have a, sir, 4 campus, sir. I'm doing it from AC Tech campus, sir.
I don't know about this, but they invited me for 2 days talk on machine learning, deep learning.
It's a big campus, the big inside a campus. The 4 campuses are inside one area. One is CEG, one is AC Tech, and this is MIT and SAP.
Okay.
The 4 campus include Anna University.
Okay.
The area is.
So I'll be there for 2 days. So one day I'll be going to SSN College.
Okay, sir.
SSN is there, no? SSN College in Chennai.
Yes.
So maybe in the next semester you can see this course, that machine learning and deep learning.
Yeah, sure, sir. We will check, sir. Definitely it will help me for my area.
No. There is no conference. This is the FDP, the Faculty Development Program. This is for the faculty members. No conference, only for the faculty development program. So this is for the faculty members. So thank you, Sahin, and other
Hello,
Dr.
sir. I
Mondo.
have one last question. I won't take more than 1 minute. I
Yes,
just want
please.
to know, is there any scope for contribution towards research paper? Like whatever is your ongoing research papers, for the people like us, can we contribute?
Yes, what actually you are doing now?
I'm working for a tech company as a AI research scientist.
Okay, so it is possible. So just because we have many collaborative projects from the government of India, like MEIT projects, DRDO projects, and also the SCRB project. So I have many projects from company. Also, I have projects. So, but how actually you can contribute? You have to see my research papers in my web page. And suppose you are interested in a particular domain, suppose in biomedical image processing or any human-computer interactions, virtual reality, augmented reality. So based on my research papers, you can select any topic, and after this, you can interact with me, so that maybe collaborative works we can consider, and or maybe the jointly we can do some research on these topics. But I am not expert in all the domains, but you can see my web page mainly on computer vision, machine learning, deep learning, virtual reality, augmented reality, and that human computer interactions. I work in that domain. So if you are interested in this domain, then maybe join publications is possible, and also the collaborative research work is possible. And also, if you are interested, then maybe from the government of India, some projects are available in DRDO, the MEIT, or maybe ANRF. I am also the member of these committees. So maybe these joint projects, maybe we can propose for this funding agencies like DRDO, MEIT, and SCRB. SCRB is now converted into ANRF.
Okay, so may I get your email ID, or I think
So you can see in my web page. You can go to my web page. You search in my web page, and you can see my research papers and also the research interest in which domain I am working. And if you are feeling that this is actually interest to you also, because without interest you cannot do anything. So if you feel this is of interest to you, then you can send one email to me. Maybe we can have a discussion, and after this we can do some collaborative research.
Sure. Thank you so much, sir.
Yes. So you are from which place?
I'm from Bangalore.
Oh, you're from Bangalore. Okay. So Bangalore, which place?
Electronic City.
Okay, I am also from Bangalore actually.
Okay. But now you are in Bhubaneswar, is it?
No, I'm in Guwahati, IIT Guwahati.
Okay.
Okay, then just we can discuss, because I used to go to IIT Bangalore, and ISRO center is there, no? ISRO for different talks.
Okay. I just recently visited in last month. No, I visited in December. There were some programs going on, so I attended the conference there.
In ISRO?
Not in ISRO, IIT Bangalore.
Oh, IIT Bangalore. I have a collaboration with IIT Bangalore. So maybe just you can interact with me, and you have to see my research papers mainly. So if you are interested, then you can propose something.
No, I'm interested. Actually, I'm following up with this NPTEL courses at every semester. Okay. I go through all assignments, and also I learn a lot of things from your videos also. So I'm quite interested in this domain.
Okay. So it is, you also see this video, no? There's machine learning and deep learning. One course is there, no? Machine learning and deep learning.
Yes, I'm following that course.
Okay. Thank you.
Yeah.
Thank you
so much. Have a nice day. Bye.
Thank you. Same to you. So I think we have to conclude this live session because we have another live sessions of another expert. So because my time is only for 1 hour, so I have to conclude. So maybe in the month of March, I'll be again coming live for the second live session of the course. The course is the Computer Vision and Image Processing, Fundamentals and Applications. So thank you for attending.